Good morning, 8th grade math. Today we're going to be doing lesson 63, rational numbers, non-terminating decimals, and percents, fractions with negative exponents, on page 429. Underneath new concepts, it reads, recall that every rational number can be expressed as a ratio of two integers. Converting the ratio to a decimal number results in a decimal that terminates, ends, or does not terminate but has repeating digits. So you see the terminating um, decimal or fraction, the first one there, 1/8. It's a terminating decimal because it's 0.125. A non-terminating but repeating is 1 over 11, and you have 0.090909 and so forth. Also recall that we can indicate repeating digits by writing a bar over the repeated. Okay, so we have 1 over 11, and that decimal is 0.0909 and so forth. So you can write that as 0.09 with a line over the two digits, 0 and 9. That means that the 0 and 9 are repeating. Okay, we do not perform computations with a decimal number that has a bar over the repeated. Instead, we use the fraction equivalent, or we round the decimal number to an appropriate number of decimal places. So, turn the page to 430, example 1. We want to express 2/3 as an equivalent decimal and percent, then express 2/3 as a decimal rounded to the thousandths place. Okay, so you have 2/3. Okay, to find the decimal, we go 2 divided by 3. So there's going to be your decimal point. Okay, so 3 does not go into 2, but it goes into 26 times. 18, 2, bring down a 0. Okay, and 6 times again. Whoops, 18, 2, bring down another 0, and it's 6 again. Okay, so we know this decimal is repeating. Okay, and we're going to do another one. Okay, and so the decimal for 2/3 is 0.6666, 0.6 repeating. Now it says to then express 2/3 as a decimal rounded to the nearest thousandths. Okay, this is the tenths, this is the thousandths, 10 thousandths, 100 thousandths, so forth. So this is the thousandths. Or no, I'm sorry. This is the hundredths, tenths, hundredths, thousandths. So we look at this 6, and it is greater than 5. So we need to round this one up to a 7. So it's 0.667. Okay? So that is your answer for example 1 when we rounded to the thousandths, which is this one right here. Okay? And it's a repeating decimal. If they told you to write it as a repeating decimal, it would be 0.6 with a line over the 6. Okay? So, example 2. We want to express 16 and 2/3% as a reduced fraction and as a decimal. So we have 16 and 2/3%. Okay? And we want to write this as a reduced fraction. So we change that into an improper fraction. 16 times 3 plus 2 is 50 over 3. Okay, and that's going to be divided by 100 because it's dealing with percents. Okay, and we compare percents to 100. When we divide fractions, we multiply by the reciprocal. So it's 50 over 3 times 1 over 100. You can simplify before you multiply. That becomes 1. This becomes 2. So 1 and 3 times 2 is 6. 1/6 is our fraction. And we want to convert that into a decimal. And one way to convert 16 2/3% to a decimal is to convert the equivalent fraction 1/6 to a decimal. Okay, so we do that by simply going, move the board a little bit, 1 divided by 6. Okay, and 1, bring down a 0, and that is going to be 6. Bring down another 0. It's going to be repeating the 6's. Okay, so your decimal here is 0.16, and you have a line over the 6. Okay. And again, if you have any questions, please don't hesitate to contact me. And you can always rewind this video and watch it again. Okay, so moving on to example 3. We want to put these in order from least to greatest. 4/5, 83 1/3%, and 0.83. Okay. If we change 4/5 into a decimal, that's going to be a 0.80. Okay. So, and this is 83 1/3%. If we change this into a percent, that's going to be 83%. If we change this into a percent, that's going to be 80%. So your least one is 4/5. So we already said if we change this into a percent, it's going to be 83%. This is 83 1/3%. So that is larger than 83%. So your next one is going to be 0.83. Whoops. Okay. And then your last one's going to be 83 1/3%. Okay. Example 4. The incumbent received 41 2/3% of the 1,260 votes cast in the town council election. Describe how to estimate the number of votes the incumbent received. Then calculate the exact number of votes. Estimating, we know that 41 2/3% is less than 50%. 50% of 1,260 votes is about 600 votes. Okay, so we know if half is around 600, we know that our actual number of votes is going to be less than 600. Okay. So if we change, we want to put 41 2/3% into a fraction. And we do that by changing this into an improper fraction, which is 125/3. And we compare it to 100. So we got to divide. And when we divide, we multiply by its reciprocal. Okay. So this becomes 125/300. Okay. We got to reduce this fraction. And we know that 25 goes into 125 5 times. So you divide by 125. Or you don't divide by 125. You divide by 25. And then this becomes 1. Oh, no, I'm sorry. I'm not thinking straight today. 5/12. Okay, so you have 5/12. Then there's a total number of votes of 1,260 over 1. And 12 does go into 1,260 105 times. So then we got to go 105 times 5. Okay, 25, that's 2, and 5. So there was 525 votes that the incumbent received. Recall, underneath example 4, recall that a negative exponent indicates the reciprocal of the positive power of the base. If you remember that we did in previous lessons, if we had, for example, 3 to the negative 2, we would put that into a fraction of 1 over 3 to the second, which would become, because 3 squared is 1 over 9. Okay? So let's turn the page. In example 5, we have 1/3, which is your base, to the negative second. Okay? So we want to reciprocate this, or we want to turn it into a reciprocal, so that to change this to a positive, so it's 3 over 1 to the second power. And the 3 over 1, or 3 squared, then is 9. That's our answer, 9. Okay? I know I've thrown a lot at you today, but if you go back over those examples, watch this video, and you can watch it more than once. It's only about 10 minutes long. It'll help you. And like I've said always, if you have any questions, let me know. And I will talk to you tomorrow. Have a great day and stay healthy.